Hello ladies and gentlemen, and welcome to the Math 12R screencast series of lessons again on geometric sequences and series, being brought to you directly from my dining room table, as most lessons have been. So geometric sequence, we're finding the next term in the sequence, and unlike an arithmetic sequence, the geometric sequence has a common ratio, not a common difference. And the way you find the ratio is you take one term and divide it by the term to the left of it. So mathematically we can represent a geometric sequence this way. So let's take a look at this. Let's do this first example. Find the next three terms in this sequence: 7, 27, 135, and 675. So if you go to your calculator and you take 675 and divide by 135, you find that your common ratio is 5. So ratio is 5. So now I take this term of 675 and I multiply by 5. 675 times 5. Next term in the sequence is 3,375, and you multiply that by 5, and you get the following term is 16,875. You multiply that by 5, and the last of the terms that you're asked to find is 84,375, because the problem asks to find the next three terms in the sequence. So these are the three terms in the sequence. So I'm sure this is very much a review of what you guys did last year. Okay, let's look at the next little topic here: to how to find a particular term in this sequence. So what we're looking here to do is find an approximation for the 23rd term in this geometric sequence. And if you look, the first term is positive 256, the next term is a negative 179.2, followed by a positive 125.44. That should give you a little indication that your R, your common ratio, will be a negative number. So again, to find our ratio, we're going to look at our last term, 125.44 divided by 179.2, negative 179.2, excuse me, and you find common ratio is negative 0.7. We know our first term is 256, and our n, we're looking to find the 23rd term. Alright, so we've got this formula up here, and that's the formula we're going to use, because that's what we need to find the 23rd term. So a sub 23 is equal to the first term of 256 times a common ratio, negative 0.7, raised to the n minus 1. 23 minus 1 is 22. So if we go to the calculator, negative 0.7 raised to the 22nd power gives you that exponential with a negative exponent. So we're going to take that and multiply by 256, and we come out with our 23rd term. Our approximation of it anyway is 0.1000914,188. It's an approximation because the calculator only displays so many digits. So we're going, in a case like this, we're looking for an approximation of that term. Let's take a look at example number 2 here. Example number 2 is we want to find the second and third terms of this geometric sequence. The first term is 48 and the fourth term is 750. So what we're looking at is something that's like this. Well, not like that. I have to erase that. Okay. So we're looking at a sequence where we have a 48, a blank, and then a negative 750. So we're looking to fill in those two terms in there. So what we really need to do is try and find the third term. Okay. Excuse me, what we really need to do is find the ratio. So we can use our formula for finding the nth term. Okay. A sub 4 is negative 750. A sub 1 is 48. And we don't know R. So if we go back to the formula for finding the nth term, A sub 1 equals A to the n, excuse me, equals the first term times ratio raised to the n minus 1. Okay, so we're going to look at our fourth term is negative 750 is equal to our first term of 48 times r, n is 4, so 4 minus 1, r cubed. So in order to solve this equation, we need to divide both sides by 48. So we have negative 15.625 equals r cubed. So in order to solve for r, you take the cube root of each side. Again, this is all calculator. So then r is negative 2.5. So if our ratio is negative 2.5, you take 48, multiply by negative 2.5, and you get negative 120. Multiply that by negative 2.5, and you get a positive 300. And then just to make sure it works, if you take 300 multiply by negative 2.5, you get negative 750. So we can use the formula not only to find a particular term, but we can use that formula to find our common ratio if we don't know it. Now let's look at a geometric series. That's the sum of a sequence. Alright, so instead of sitting there and trying to add all those together, like to find the sum of the sequence, we have a formula for that. Okay, so the sum of a geometric series is the number of terms. Right, then so we want the S sub n is the number of, let's say, the first 10 terms. Okay, is equal to the first term minus the first term raised times r raised to the number of terms, whatever that power is, over 1 minus r. And again, you'll have all these formulas on a quiz or a test, so there's no need for you to remember them. The important thing is you need to know how to apply the formula, and you need to know which formula it is that you're that you need to solve a problem. Okay, so again, let's take a look at this formula. What's the first term? Minus the first term times r raised to the n over 1 minus r. Okay, so we are looking for the sum of the first 8 terms, and that's equal to the first term of 3 minus 3. Oh, we didn't find our R here, which is -2. 3 times -2 raised to the 8th over 1 minus -2. Our common ratio is -2. Okay, so then we look at this. -2 to the 8th is 256. 256 times 3 is 756. So it's 3 minus 756 over 3. 2 minus -1 is 3. So when we combine the like terms in the numerator, we wind up with -765 over 3, which equals -225. So -225 is the sum of the first 8 terms of this geometric series. So if you need to go back over any of these, please do so. Check the screencast. Let me see if I can get rid of this black squiggle line here. Delete. There it goes. Okay. Go back and replay the screencast. We'll go over these in class. Let me leave that on the screen for just another minute so you'll be able to get that down. So thank you for tuning in to this latest edition of Math 12R screencast lessons, and being brought to you again right from my dining room table. I'll see everybody in class.